Okay, this lecture is over Chapter 8 of your textbook, which is titled Intrusion Detection Systems. So first, what is an intrusion detection system? It is something that monitors host activity and/or network activity and looks for compromises or things that it considers not normal and reports on those. We talked about in the past how an IPS, an intrusion protection system, does the same thing as an IDS, but then it acts on that information, trying to mitigate the issue. So in this chapter, we'll talk about what exactly is an IDS. We'll talk a little bit about IPSs. We'll talk about several common intrusion detection systems. We'll talk about a common architecture for IDS systems, and we will talk about alerting from an intrusion detection system. So going back to an IDS, a formal definition would be a cybersecurity tool that monitors network traffic and/or system activities looking for malicious behavior, security policy violations, and/or unauthorized access attempts. The first widely recognized IDS was something called IDES, which stood for Intrusion Detection Expert System. It was developed in the 1980s. And that term, expert system, it's been decades since I heard that term, but that was, in my opinion, kind of the predecessor of AI, was expert systems. There are some lesser known ones that were available in the early 1980s, as early as 1980 itself, but they were not widely available or used. There's different ways that IDS can detect anomalies. The first is signature based. This is what most antivirus software uses. Somebody determines a pattern to the code or behavior of a certain attack or virus, and that pattern is referred to as a signature. And network traffic or files or memory, in the case of a host based IDS, it will look for that signature, and if it finds it, it will report it as something that you probably need to look at. There is also a detection style referred to as heuristic, and it looks for things that is considered abnormal and reports on those. There are now AI-based ones that use machine learning and behavior analysis to attempt to identify threats. A host-based IDS, as the name implies, focuses on activity on a host, that is, on a computer or device. Well-known host-based IDSs are OSSEC, WASH, Tripwire, and Microsoft Defender for endpoint. Here in a moment, we'll go back and talk in a little more detail on Tripwire and OSSEC. And there are many others. There are network-based IDSs. They monitor network traffic and try to detect suspicious activity on the network. Well-known network-based IDSs are Snort, Suricata, Zeek, Cisco's Secure IDS, and many others of those as well. Snort is one of the tools that your book talks about. It is named Snort because that is the sound a pig makes when it's sniffing. And you'll recall that looking at network packets are referred to as sniffing the network. So that's how Snort got its name. Currently, it is maintained by Cisco. and it is open source, and there are many add-ons that you can get for it that cost money, and you can also pay for support so that if you need help with it. So technically it's open source and free, but there are some things that might cost you money if you need to use them with Snort. Source code is downloadable from snort.org, and it can be run on Unix, Linux, and Windows systems. The architecture of Snort is it has things referred to as preprocessors. These examine and modify the network traffic before it reaches the rule engine, which we'll talk about. So, for example, if you just consider ICMP, packets and conversations noise, you can tell it don't pass that on to the rule processor, just eliminate it. So by modifying it, it doesn't actually modify the packets themselves. It modifies whether you see them or not, would be more accurate. Then there is the configuration part of it, and this tells Snort how to behave, what traffic to inspect, and what actions to take if a threat is detected. So this is more traditional configuration of the software and its behavior. The rules are the heart of Snort. Rules are the detection logic of Snort. So you write rules or find rules that help you detect threats. One little side note is these rules and a lot of tools that are used in cybersecurity rely upon regular expressions, sometimes referred to as regex. You will have a lecture on regular expressions appear in Blackboard right after this one, and then you will have at least 2 homework assignments that focus on regular expressions, and then you may be using regular expression in later homeworks related to other tools that we might be using in this class. Suricata and Sagan, they're similar to Snort, and they can use Snort rules. They can generate the same output as Snort. It is configured using YAML. And when it was developed, the big differentiating thing was that it was multi-threaded, and Snort was not at the time. However, with Snort 3, also referred to as Snort++, Snort is now multi-threaded. And if you don't know that term, it basically means there can be multiple processes running, executing different parts of code from a single program. So multiple things can be going on at the same time. There's something called Bro. It was called Bro originally. It's now called Zeek. It is similar to Snort, and it can also use the Snort rule sets. It can also use the same output as Snort. It uses YAML as well. And obviously, what I have here is not related to Bro. I'll have to go back and correct that. Tripwire was developed in the 90s and open sourced in the year 2000. It is a host-based IDS. How it behaves is it creates hashes for all the files on the file systems, or at least the file systems you tell it to watch, and then it watches for changes in those hashes and reports them to you so that you can determine if somebody's altered your machine. OSSEC was released in 2004. It is a host-based IDS as well. It does what Tripwire does. However, OSSEC also will check for rootkits. It will do log monitoring, and it will do process monitoring as well. So in addition to looking for files, it will look at logs and processes as well to try to find compromises. As far as IDS architecture, this is how it is set up. And one of the most common ways, and therefore the only way I really talk about here, is that you have something that is often referred to as sensors or that are spread around and collect information for different parts or different devices within a portion of your network, and then it sends all that information to a central collector, which can then report on all the data that was seen by all the sensors. As far as alerting, this is what an IDS does when it determines that it thinks something is wrong and wants somebody to look at it. So there are different ways that these alerts can take place. You can have consoles or dashboards that are running and displayed and turn an icon red or flashes an icon at you if it determines that a device or machine may be compromised. It can write these alerts to files. Oftentimes it might do both of these. It might try to get a person's attention, but for review at a later point in time or for evidence, writes those alerts to a file as well. It can use syslog forwarding. We talked about syslog recently. So this would be kind of similar to the collector. You would have a main syslog instance that would be referred to as the collector, and syslogs on a number of devices would send information to that central syslog server. You can have email notifications and you can have SMS notifications, and there are other ways that IDSs can alert, but these would be the most common. So that ends up the lecture on intrusion detection systems.